Section: Introduction. In this section, we discuss the advantages of large language models, LLMs, for businesses, which can automate tasks like customer support, text summarization, and more. To fully utilize LLMs, we need to create effective prompts that clearly outline the task and desired outcomes, including any specific preferences. These tailored prompts help the LLM understand what we want, leading to better results. However, designing and optimizing these prompts, known as prompt engineering, PE, can be complex and time-consuming, requiring a deep understanding of how LLMs interpret instructions. To ease this process, recent studies have looked into automating PE, but they often rely on labeled data, which can be hard to obtain, especially for generation tasks. Additionally, these methods usually require users to provide initial prompts, which is not always straightforward. We propose a new method called Conversational Prompt Engineering, CPE, which eliminates the need for labeled data and initial prompts. The main idea is to use chat models to help users create prompts through a simple conversation, using a small amount of unlabeled data they provide. CPE is built on three key insights. First, users often find it difficult to clearly express their tasks and expectations. Advanced chat models can help users articulate their needs more effectively. Second, for a given task, LLMs can analyze unlabeled input texts to suggest specific output preferences, helping users refine their requirements. Lastly, user feedback on model-generated outputs can be used to improve both the outputs and the instructions for future tasks. The prompts generated by CPE are few-shot prompts, incorporating user preferences and examples from the conversation. CPE is particularly useful for users who need to perform the same task repeatedly, such as summarizing emails or creating personalized ads. Our implementation of CPE can be applied to various tasks, including topic generation and creative writing, but we focus on summarization in our evaluation due to limited annotators. The rest of the paper is structured as follows. We provide an overview of CPE from the user's perspective, describe its design and implementation, and present results from a user study demonstrating its effectiveness. In the related work section, we note the growing interest in improving prompt quality due to its impact on LLM performance. Strategies like chain-of-thought prompting enhance in-context examples with reasoning steps. Other studies focus on automatic prompt improvement, using methods like trigger tokens and iterative processes for refining prompts. While these approaches share similarities with our work, CPE stands out by offering a natural chat-based interface that engages users in discussing their preferences and directly incorporates their feedback into prompt revisions. Additionally, various tools have been developed to help users utilize LLMs, such as PromptBase, which allows users to buy and create prompts. However, unlike PromptBase, which relies on a single initial prompt, CPE uses multiple predefined prompts to guide the conversation, reducing the user's cognitive load and effectively gathering relevant feedback. Section Summary. In this section, we introduce Conversational Prompt Engineering, CPE, a user-friendly approach that helps users create effective prompts for large language models, LLMs, without needing labeled data or initial prompts. CPE leverages chat models to clarify user requirements, utilize unlabeled data for output preferences, and refine prompts based on user feedback, making it particularly useful for repetitive tasks in enterprise settings. Section: System Overview. In this section, we provide an overview of our system and clarify some key terms. CPE refers to our implementation that includes a user interface and a chat framework involving three parties. The target model is the specific model we format our prompts for. An instruction describes the task and the expected output, but it does not include examples. The CPE instruction is the final task description approved by the user. A prompt is the input we give to the language model, formatted according to the target model. The CPE-ZS prompt includes the final instruction without examples, while the CPE-FS prompt includes examples that the user has approved. User data consists of at least 3 unlabeled examples provided by the user. Prompt outputs are the results generated by the model when we use a prompt based on the user data. Our main goal with CPE is to assist users in creating prompts that will yield outputs that meet their needs. We outline the process from the user's perspective, which typically involves several stages. 1. Initialization. This step has two parts: selecting the target model and uploading the user's unlabeled data file. 2. Initial discussion and first instruction creation. We analyze 3 examples from the user data and discuss the task and output preferences with the user. For instance, if a user uploads 3 movie reviews and wants a summary, we might ask if they prefer focusing on the plot or the reviewer's opinion. If they want both, we could suggest an initial instruction like summarizing the plot and the reviewer's opinion. 3. Instruction refinement. We revise the instruction based on user feedback, which can relate to the proposed instruction or the outputs. For example, if the user wants bullet points, we might adjust the instruction accordingly. 4. Output generation. We use the latest instruction to create a prompt for the target model, generating the corresponding outputs. 5. User feedback and output enhancement. The user reviews the outputs. If they approve, we move on. If not, we refine the outputs based on their feedback and suggest a modified instruction, returning to the refinement stage. 6. Convergence on CPEFS prompt. The chat concludes once the user approves the instruction and all outputs. We then share the CPEFS prompt. Stages 3 to 5 can repeat until the user is satisfied with the outputs. While this flow represents a typical interaction, we allow users to navigate freely, ask questions, or end the chat at any point. We access CPE through a web interface with 3 modules: Chat, Survey, and Evaluation. The Chat module is where we interact with CPE, and the interface also allows for actions like uploading data or downloading the CPEFS prompt. In our system, there are 3 key participants: the user, the model, and the system. The user communicates with CPE through the interface. The model, which is a language model that performs data analysis, discussion, instruction refinement, and output enhancement, responds in a specific format. We use Llama 3 to 70B for this purpose. The system manages the interaction between the user and the model, triggering actions based on the model's responses. Unlike typical setups that use a single initial instruction, we employ multiple dynamic instructions throughout the chat, giving us more flexibility and control. Section Summary. In this section, we outline the CPE system, which facilitates user interaction to create tailored prompts for a target model, enhancing output alignment with user requirements through iterative instruction refinement and feedback. The process involves initialization, discussion, output generation, and user feedback, all managed via a web interface that supports dynamic interactions among the user, the system, and the model. Section: Context Management. In this section, we construct the context for each message from the system to the model individually. We implement a context filtering mechanism that allows us to manage the context given to the model during the conversation. This mechanism is motivated by the limitations on context length. After generating the initial instruction, the model interacts with the user to discuss 3 text examples. While discussing each example, we use a filtered context that excludes messages from other examples. We also use this mechanism for side chats, where we need to focus on specific parts of the conversation. For instance, when we want to test a prompt outside of the CPE context, we create a side chat with the target model that includes only the relevant prompt. We employ chain of thought, COT, in side chats when we need to guide the model more carefully. For example, after receiving user feedback on prompt outputs, the model summarizes the user's comments in a side chat. Once we have these summaries, we ask the model to suggest a new instruction based on them. Regarding API calls, we guide the model's responses using predefined functions. For instance, we use submit_message_ to user for messages meant for the user, and submit_prompt after the user approves a proposed instruction. This leads to generating outputs for user data in a context-free side chat. We also have functions like switch_to_example to discuss specific prompt outputs and end_outputs_discussion to wrap up once all outputs are approved. CPE operates as an agentic workflow, allowing LLMs to perform complex tasks autonomously with user involvement. We break down the task of generating personalized prompts into smaller subtasks using reflection and COT techniques. The system actor communicates these subtasks to the LLM through prompts. CPE utilizes various tools via API calls, including a prompt execution tool. The system actor's instructions include placeholders for information from these tools, enabling the model to use this information in the chat. To evaluate CPE's effectiveness, we conducted a user study with 12 participants focused on summarization tasks. Participants selected data from unlabeled datasets and engaged in open-ended conversations with CPE, followed by a survey rating their satisfaction with the CPE instruction and the overall chat experience. They also evaluated summaries generated from different prompts, including a baseline and 2 CPE prompts. The survey results indicate that CPE effectively meets user needs, although participants noted a longer convergence time, averaging 25 minutes. We plan to improve this in future work. Our analysis shows that, on average, chats required 32 turns to reach convergence, with many users refining their instructions through multiple iterations. We found significant differences between initial and final instructions, highlighting CPE's potential to enhance task requirements effectively. Section Summary. In this section, we describe our context management approach, which filters messages to control the information provided to the model during conversations, addressing context length limitations and enabling focused side chats. We also outline our user study, which demonstrates that the CPE system effectively integrates user preferences into prompt generation, leading to improved summarization outcomes while highlighting areas for future enhancement in convergence time. Section Discussion. In this section, we introduced CPE, a new method designed to assist users with the important task of prompt engineering, especially for those working on repetitive tasks with large datasets. Our user study, which focused on the challenging task of summarization, showed that CPE effectively generates prompts that lead to responses meeting users' expectations. We also see an interesting question about whether the prompts created by CPE could be enhanced by using them as starting points for existing automatic prompt engineering methods. Furthermore, we believe it would be exciting to explore the use of CPE beyond just generating prompts. Given the recent interest in systems powered by large language models, we think it would be beneficial to investigate how CPE could help users in planning and developing workflows for these agent systems.